If I walk into a boiler room and see a master trap on the condensate pipe, I can't help but cringe. My spidey sense screams to run, not walk away from this place and never come back. Why, might you ask? Stay tuned and I will tell you why this is a huge mistake. I'm your boiler room detective, Ray Wolfarth, and the title of this week's case is The Master Steam Trap Mistake, Why It's Costly, Dangerous, and Outdated. What's a master steam trap? A master steam trap is typically installed in the main condensate return pipe before the condensate or boiler feed tank. At first glance, it seems like a sound mechanical idea. The installer believed it would stop the steam from leaking from the tank, and it does, but it creates many more problems than it solves. What problems, you may ask? No temperature control. With only one trap, there is no way to regulate the discharge of the condensate from individual components. That leads to poor temperature control, especially in systems with multiple coils, radiators, or heat exchangers. Number two, there's the risk of water hammer. Without traps at each terminal unit, condensate backs up into the piping, setting the stage for dangerous condensate-induced water hammer. That puts strain on the piping, valves, and fittings, not to mention the technician and the owner's nerves. Number three, you have inconsistent heating. Some parts of the building will overheat, while others remain cold because the steam can't reach evenly through the system. Number four is system damage. Master traps often lead to corrosion in the return piping and premature failure of the system components due to pooled condensate and oxygen-rich water. Number five, code and best practice violations. Modern-day design standards call for individual traps at each terminal unit to ensure proper drainage and system balance. I learned this lesson the hard way. We bid on a replacement steam boiler project and were awarded the project. After the boilers were installed, we started getting comfort complaints. Since we installed the boilers, we were blamed for the system problems, with the usual complaint, "This didn't do this with the old boilers." We knew it wasn't true, but what were we to do? Talking with the building's maintenance tech, John, I asked about the master trap. He proudly bragged that it was his idea, explaining the steam was filling the boiler room. The leak stopped when he installed the trap. We also discovered that John removed all the steam traps in the apartments. When he got comfort complaints, he would raise the steam pressure. The old cast iron boiler was set at 10 psi. The pressure differential across the trap dictates the capacity of the trap. The higher the pressure differential, the greater the discharge capacity. The lower the differential, the lower the trap capacity. On a properly working steam system, there will be steam pressure, typically 2 psi, on the trap inlet and condensate at atmospheric pressure on the outlet. The steam pushes the condensate through the trap and into the condensate pipe. If there is steam on each side of the trap, the pressure differential goes away. The only way to move condensate from the radiator or pipe when the steam is on both sides is for the water to rise and use the weight of the water to push it. This will lead to steam and condensate meeting and the pipes start banging. Final thoughts. If you're bidding on a job and see a master steam trap, consider this your sign to run away, or at least bid high, knowing you're inheriting a mess. Steam systems need precision, not shortcuts. Please like, subscribe, and share this video if you found it helpful. My boiler books are available at Pronto Heating Supplies in New York, T.F. Campbell in Western Pennsylvania, and on Amazon.com. My articles are found in these magazines. Thank you for watching, and I look forward to seeing you on the next case.